Yeah, I'm making this little tool here. I finished doing these cuts. Okay, so this is roughly what I'm looking at for a tool. Is I've got one of these bearings. These are the guide bearings that I use on my bandsaw. So they have a 10 millimeter bore, and so I've got a 10 millimeter bolt there. And what I'm going to do is drill and tap a hole in this block of aluminum to screw that in down there, and then what I'll do is make a sleeve so it goes down to the threaded part, and that'll just have a 10 millimeter ID in the sleeve, so then I can tighten this bolt down into this and basically have this bearing sticking out on the end. I got the metal hogged out. Now I just need to get in the center here, drill a hole and tap it. I think I'm ready to try crimping one of these bezels. So what I have, I machined a block of UHMW rod here and cut a recess just deep enough to fit about half the bezel into. Yeah, so I machined down about an inch long piece of aluminum to fit in here. It's just longer than the pressure fitting and then the two threaded studs. So I don't have this very tight. I just have it tight enough to hold and give it a little bit of friction. So yeah, I've got my roller bearing crimping tool in here, and it's a really tight fit. I'll show you what it looks like from this side, but I wanted to get it shooting in here so you can actually see it working. And I'm going to feed the cross slide in, and I've got the bearing at an angle, so as it moves in, it's going to roll that over and hopefully crimp that around the back of the gauge. So let's see what it looks like here. And I've got the lathe on my slowest speed. So now that the roller bearing is spinning, it's made contact. See that spinning over, and yeah, I think it's doing its job. Let me check here. Yeah, I got enough clearance here. Let me move out, and I'm going to move the carriage a little farther forward. You can see how the bezel is kind of crimped over the outside of the gauge. So what I want to do is I'll pull it out here. I just want to see how tight the bezel is. So we can slip that out of here. It's still a little bit loose, you can see. Okay, I think I've got things fixed up here. What I did was I trimmed down the edge of my holder here, so there's a little bit more of the bezel exposed, and I also filed it back at like a 45-degree angle. And then the other thing I did, I ground off one side of my bolt here. It's got a hex head bolt, and I just shaved off the one corner that was hitting here. So the outside of the bearing just is touching the very edge of the bezel, and then I'm going to feed it inward, and hopefully that'll push it over. Okay, yeah, we got it rolled around quite a ways there. Yeah, it's still a little bit loose. Yeah, I wonder if I can get the tool turned around a little bit farther there. Okay, that was my original bezel holder that I just machined out of a piece of 2-inch round stock there. This one worked, but it was a little bit slippery. This is UHMW polyethylene, so it's a very slippery plastic. It did work, but I needed quite a bit of force applied to the back of the gauge to hold this in place. Figured I'd 3D print one. This is printed in ABS plastic, and it's kind of got the same problem, but what I found that I think will help is these bezels typically have a raised ridge on the inside, and then they're rolled on the outside here. And so what I did was I modified my CAD file and put a recess there. So there's actually 2 dimensions you specify in the OpenSCAD file. One is the outer diameter of the whole bezel, and then the other one is the outer diameter of this inner ridge. And then the other two dimensions you have are the depth you want this to sit in there. I have it set for about 2 millimeters because you need to leave most of this outer ridge exposed. If you cover it all up, there's no way you can roll it over. There's also the width of this ridge. For instance, this one I think was 47 outside. The inner diameter was 43, and then the width was 2 or 3 millimeters. And what that does, and it just leaves a second recess here in the middle. That drops in there really solid. And then just to give it a little more grip, I gave this 2 coats of a truck bed liner spray, and that gives it a little bit of a rubbery surface and a little more friction. So I think that's going to work well. And you can see here I've still got adequate exposure of that ring so I can roll that over. And then the other thing I did was I made it a little bit taller so that I had more clearance here to the jaws on the chuck. Okay, yeah, trying out the new gauge holder, whatever you want to call it. I think I need to turn the bearing, get it out like that. Let's see what that looks like. You got to get the bearing just at the right angle, because if I have it too far over flat, the bolt head hits the can of the gauge right there. And if you go too far this way, you can't flatten the bezel out. So let's see what that looks like. Boy, and you can see how rock solid that is in there. I mean, it doesn't move. That's there. Look at that. Yeah, that's solid in the back. Now this one is tight, but the bezel is a little bit loose. This one, the bezel is pretty tight. Yeah, you can see the bezel on this one is tight, but I think the glass is a little loose.